You are welcome to today's teaching with Anakwe Christopher Ejike, your chemistry teacher. I want us to start by asking you, what happens when you add HCl or sodium hydroxide in water? What do you think that happens? Oftentimes, of course, if you have witnessed it in the lab, of course, definitely when you add sodium hydroxide in water or HCl, of course, it dissolves. But that substance that you think that dissolves, something happens. Of course, something happens when it does that. Sodium hydroxide definitely will ionize into the solution. HCl will also ionize into the solution, but they will break into ions. Sodium hydroxide will break into sodium ion and the hydroxide ion. HCl will break into hydrogen ion and the chloride ion or chlorine ion. Now, that thing that happened that way, in chemistry, a man postulated, and they said that it's not every substance that can do that thing. Of course, some substance can dissolve in water, but they will not produce those ions. And it called those kind of substance that can dissolve in water that way and produce ion, we call them electrolytes. And it's under a theory we called Ionic Theory. And this will lead us into the topic we have today, Ionic Theory. Our topic for the day is Ionic Theory. It is expected by the end of the class, you will be able to learn or explain what Ionic Theory is. Again, you will be able to define electrolytes and non-electrolytes. By the end of the lesson, you will be able to list at least 4 examples of electrolytes and 4 examples of non-electrolytes. Then lastly, you will be able to differentiate, at least state 4 differences between electrolytes and non-electrolytes. Let's begin by looking into what Ionic Theory is and what it says. Ionic Theory is of the view that when an electrolyte is melted or dissolved in water, some, if not all, the substance breaks. It breaks up, or we call it dissociates into free-moving charged particle called ion. Just like what I explained before, when sodium hydroxide or HCl dissolves in water, it breaks into ions, of course, into positive ion and the negative ion. So that is what Ionic Theory is of. That is what it is saying, that when an electrolyte dissolves in water, it breaks up, it dissociates into a moving charged particle, into moving ions, charged particle called ion. And this process of dissociation is what we call ionization. They ionize, they break up completely. However, some may break partly. That is why it says some, if not all, the substance breaks up. That is what Ionic Theory is saying. Now, Ionic Theory is of the view that when an electrolyte is melted or dissolved in water, some, if not all of it, of the substance, breaks up or dissociates into freely moving charged particle called ions. All right, when an electric current is passed through such electrolyte that dissolved, still remember that dissolved into free-moving particles, then those ion, free-moving particles, those ions they will move. They can't stay one place. They are now free to migrate, to move. Then the positive charge of that particular ion, they are now attracted to a cathode. And we call those ion, positive charged ion, cation. Why? Because they move to the cathode. That means cathode ion. They will be attracted to that cathode, and that is why we call positive charged cation, because their ions are the cathode. Then the negative ions, just like a hydroxide ion or chlorine ion and all of the negative charged ion, they will be attracted to the anodes. And that is why we call the negative ions anions, because they are anode ions. So once it breaks, it begins to move. It won't stay in a place. They are now free to move. And they move respectively according to the cathode, the electrode that is being attracted to that particular ions. All right. Now, what do we mean by electrolytes? What is an electrolyte? An electrolyte is a compound that conducts an electric current when it is in multi or in aqueous solution. A particular compound or a substance that conducts an electric current when it is in multi-form or in aqueous solution. Why are we putting it that way? Because we still know that there is a thing in sciences or in chemistry or science-related courses that we call conductor. We know that that one, of course, it conducts electricity, but it's in solid states. So this one, it conducts electric currents when it's in multi-states or in aqueous solution. That means in order to conduct that electric current, such substance must break into moving ion, into mobile ion that can allow the electrodes now to get attracted to those particular ion that they will be attracted to. Cathode will be attracted to the positive charged, while the anode will attract the negative charged particles. Then, by that, we have what we call electrolytes. So those compounds that can ionize into solution and they break into movable ions and allow electric current to pass through them is what we call electrolytes. What are they? All ionic compounds are electrolytes. You will still remember when you did your electrovalent compound or electrovalent ionic compound, covalent compound, and the metallic and all of that we did. Those ionic compounds are electrolyte because of what? They can ionize into the solution. All right, so they are the electrolytes. Then when ionic compound dissolves, when ionic compounds dissolve, they break apart, of course, as I said before, into what? Into ions, which are then able to conduct electric currents. Examples. So if you are asked to give examples of electrolytes, simple, you can give the ionic compounds like sodium bromide, potassium bromide, sodium chloride, potassium chloride, sodium fluoride, potassium fluoride, sodium calcium chloride, potassium oxide, sodium oxide, magnesium oxide, etc. So many of them, even the insoluble potassium triosocarbonate 4 we know is also an electrolyte, because this time it can, when it's in multi-form, it can conduct electricity. So ionic compounds are electrolytes. So as many ionic compounds you can remember are electrolytes. Now, what are now non-electrolytes? Since we have defined electrolyte, of course, it's an opposite of electrolyte. A non-electrolyte is a compound that does not conduct an electric current, either in aqueous solution or in a multiform. They do not conduct electric current, either in aqueous solution or in multiform. or in multi-state. Non-electrolytes primarily are being held by covalent bonds, not ionic bond, rather ionic bond, covalent bond. But electrolytes are being held together by what? Ionic bonds. So non-electrolytes are covalent compounds. That's simple. The best way you can easily know them. Examples of that is glucose. Of course, it's soluble in water. We know that one. It is soluble in water, but when it dissolves in water, it does not dissociate into ions. Still remember, the ions are the main thing. They are the electric current charges. They are the ions are the electric carriers. If it cannot produce ions, no matter how soluble it is in water, it cannot conduct electricity. So glucose, of course, it can dissolve in water, but it does not produce ions. So it's a non-electrolyte. We still have many other organic compounds like sugar, ethanol, benzene, ether, trichloroethane, and many others. They are non-electrolytes. When all these, when they dissolve in water, of course, they do not produce ion. Definitely, they will not conduct electricity or electric current. Hope you can differentiate between electrolyte now and the non-electrolytes. Okay, we can classify the electrolyte into two. Classification of electrolytes. Electrolytes can be classified into strong electrolyte and weak electrolyte based on their ability to conduct electricity. Of course, electrolytes, of course, we know that they are ionic compounds, but there are some that are strong that can conduct, can ionize completely. Some can ionize slightly. So depending on their conducting power, ability. So strong electrolyte and weak electrolytes. What are the strong electrolytes? Strong electrolytes are the strong acids, strong bases, and salts, which are the soluble salts. We mean the soluble salts. Weak electrolytes are the weak acid and the weak bases. These are the simplest way you can get them. Now we will now talk what are the strong. What does it mean that an electrolyte is strong? An electrolyte is strong when it ionizes. When it ionizes completely. So strong electrolytes are substances which ionize completely in solution and they conduct large current of electricity. For the fact that it can ionize completely in solution, we call it strong electrolytes. So the ions are free to move. They are free to move. Still remember strong electrolytes, as we said, the strong acids, which are the HCl, H2SO4, HNO3. These are strong acids or mineral acid, as the case may be. Strong bases, we can have sodium hydroxide, potassium hydroxide. We have soluble salts, sodium chloride, potassium chloride, and all of that. Soluble bases, we can call them also alkalis. So these are the examples of strong acid, as the case may be. So if you are asked to list 4 or 5, with what I have said, you can list 4, 5, 6, or 7 of the strong electrolytes we have, or what electrolytes are, the examples. Now, what are the weak electrolytes? Still remember that both strong and weak electrolytes, they are all electrolytes. But in case if you are expected to differentiate them, weak electrolytes, of course, they ionize, but they ionize slightly. So for that reason, they do not conduct electricity readily the way the strong acid do, the way the strong electrolytes do. So something like ammonia solution, ammonia in water, ammonia aqueous. Ammonia actually, when it dissolves in water, it forms ammonium hydroxide. Ammonium hydroxide is ammonia aqueous. And when it ionizes, it will produce ammonium ion, and the hydroxide ion. But it does not ionize, as you can see, it doesn't ionize completely the way the strong acid does, the way the strong electrolyte does. So we still have other organic acids which belong to the family of weak electrolyte. They are electrolyte anyway, but they do not ionize completely. What are they? Ethanoic acid, tartaric acid, citric acid, even water. Water is also an electrolyte, but it's a weak electrolyte. Of course, we know now that water conducts electricity very, very well. So, but compared to the strong electrolyte, it can be classified into weak electrolytes. So these are the electrolytes. So far, we have been able to point them out. We have pointed them out and the examples. Now let's move to the differences between electrolyte and non-electrolyte. We have talked about electrolyte. We have also talked about non-electrolyte. Can we differentiate them in case if it's been asked or if it is being required of you in your exams? So we'll compare them based on we'll use some basis to differentiate them. We'll differentiate them by comparing them with some things. Number one is that we're going to differentiate them based on their definition. Definition: electrolytes are chemical compounds that can break down into ions when dissolved in water. But non-electrolytes are compounds that does not conduct electric currents, either in aqueous solution in a multi form. That is it. You can use their definition to compare them. Another one is that you can compare them based on their electrical conductivity, the ability to conduct electricity. Of course, electrolytes can conduct electricity through their aqueous solution, while non-electrolyte does not conduct. Non-electrolytes do not conduct electric current through their aqueous medium or solution. So you can compare them through their definition. You can compare them through their electrical conductivity. You can still compare them with as regard to their chemical bonding. I stated it before that electrolytes are composed of ionic bonds. Ionic bonds. In their bonding is ionic bonds they belong to, while non-electrolytes are composed of covalent bonds. Covalent bond. But in terms of compound, when you compare them in terms of compound, electrolytes are ionic compounds. The acids, the base, and the salts, these are electrolytes. We have them there. But non-electrolytes, we have covalent compounds, carbon-containing compounds, like fats, sugar, and all of that we talked about before, both the ethanol and the hydrocarbon compounds. These are non-electrolytes because they do not do what electrolytes do, as we have stated before. Lastly, on their comparison, now we can compare them even in the types. The types they are, the way they exist. Electrolytes can be found as a strong electrolyte and weak electrolyte, while non-electrolytes cannot be found that way. Rather, they can be found as either soluble compound and insoluble compound. These are the comparison we can give to them by differentiating them. So far, we have done so much in talking about what electrolyte is and non-electrolytes. Now, we want to talk a little on this so that the next video will start from where we stop and migrate to the next thing. Now, we have what we call electrochemical series. We have what we call electrochemical series. Now, electrochemical series is also known as activity series. It is the series of chemical elements in order of their standard electrode potential. Now, the activity series or electrochemical series is the arrangement, order of reactivity of elements, in the order of their reactivity, As we can see, potassium is at the topmost, at the metallic part of it. Sodium, calcium ion, magnesium ion, aluminum ion, zinc ion, iron 2, tin 2, lead 2, hydrogen ion, copper 2, and silver ion. As we can see, that is the order of their reactivity. Why are we bringing that? Because we said before that when these ions break, when an electrolyte breaks, they break into ion, and those ions migrate to the electrodes. Of course, as they migrate, they don't just migrate like that. They migrate according to the reactivity. Still remember that whenever electrolyte is being added to in water, water all itself will also break into ions. And that electrolyte that will also be added will also break. So which one will move to electrolytes has to do with each of electrochemical series. As we can see it for both anion and the cations. We will talk more about this electrochemical series in the next class. All right, so far we have talked about electrolyte. We said that when electrolyte is being melted and dissolved in water, such substance will break into free moving particles called ion. And the positive ions is what we call cation, which is the cathode ion, and the negative ions are what we call them anions because they are anode ions. We still emphasize that in order for it to conduct electric current, such substance must break into movable ion. That means electrolytes conduct electricity when they are in motive form, when they are free, the ions are free to move. That is what we have been able to do in our class today. All right, thank you. As you take these assignments, wire questions, you have to explain why sugar or common salt do not conduct electricity in their solid states. Why sugar or common salt, which is sodium chloride, why they do not conduct electricity in their solid state. Then you are also to identify each of the following substances in aqueous solution as strong electrolytes, weak electrolytes, and the non-electrolytes. You can see the compound there, sucrose, ammonia, and the sodium hydroxide. Which one is strong electrolyte, which one is non-electrolyte, which one is weak electrolyte, based on what I have taught you now. Lastly, now you are going to define what is an electrolyte. These are wire questions. The previous one, and the number one is wire question 2010, number 3 question, theory. And define what is an electrolyte. Then you have to classify each of the following as strong electrolyte, weak electrolyte, or even non-electrolyte: potassium chloride, sodium ethanoate, aqueous ammonia, cane sugar. WAEC 1998, number 14, A and B question. That is it. Thank you very much for being there with me. All right, for further study, you are going to use your essential chemistry, understanding chemistry, and the new school chemistry. Still make use of your compiled past questions. For the submission of this assignment that has been given, send it to my WhatsApp line, 080-655-73229. 080-655-73229, or you can send it to my email address at christo116@gmail.com. at christo116@gmail.com. Thank you for listening.